Okay. Whenever you're ready, Kaushik.
Okay.
1 second. Everyone's here, right? Oh no, hold on. One person is coming. Okay. Okay, Kaushik, you can go ahead now.
Can you see the screen?
Yeah.
Okay. So hi guys, I'm Kaushik. I'm a PhD student here at the AI Institute. And so I'll talk about how to use AI systems, particularly chatbots for virtual health assistants. So what that means is that there are a lot of health applications that could benefit from the use of chatbots. For example, mental health is one of them, where the patients and therapists, they don't get to meet very often, and a virtual health assistant that can interact with the patient to keep them their mood up in the meantime can be of great benefit to not just the patient but also a valuable tool for data collection for the therapist. So things like that. So we'll see a few examples. So until this point, I'm assuming that a lot of you have already played around with ChatGPT. Uh, that is sort of the quintessential chatbot where you talk to it about whatever you want, and it's quite generic and it responds according to the context in which you're speaking to it. So generic chatbots are great, but when you want to handle something domain specific, for example, you need the chatbot to have uh, knowledge about medical terminology and what to do in cases where doctors would know how to behave, then these generic chatbots cannot work in those settings. So we need to do something differently. Um, so to give you a bit of history, uh, this effort towards making virtual health assistants is not new. In fact, this chatbot called ELISA uh, came out in 1966, and it was supposed to be a psychotherapist, and you can talk to it, and it would counsel you on whatever was bothering you. So what we can do is try and talk to Eliza for a little bit, so you can see how it works. So I'll use the same script that is on the screen while talking to it. So you'll see here now. Sorry. Yeah, here's Eliza. So the first thing that in this script the person says is men are all alike. So if we go over and type men are all alike, it says how. So it's deviating from the script that you see here. So the back end of the ELISA chatbot has a bunch of rules and sometimes multiple rules for a single input text. And so one of them fire. And so then what you see on the screen is a small variability in the responses. So the chatbot that you saw online said how instead of what is the connection do you suppose. Uh, let's try one more thing. They're always bugging us about something. So they are always. And it says, what are you thinking of? So in this case, the chatbot said, can you think of a specific example? And online it said, what are you thinking of? So you can see how they're somewhat similar, those two responses. So in essence, at the back end of ELISA, there's a script, there's a predefined script. Although to people that used it back then in the 60s, it appeared as if ELISA actually understood what they were saying and responded in an intelligent manner. So, uh, and it created quite the media presence at the time that people were saying that chatbots will be solved in the next 5 years, but it was not. But so the effort towards making chatbots has been around for a long time. Um, so here is a little bit of the timeline. 1966 is when ELIZA came out, and then 1994, several decades later, is when someone actually used the term chatterbot to describe these kind of things. And in 2001 is sort of the um, start of the century when data became available. People were starting to message each other, and that kind of back and forth conversation data started becoming available to software companies. And so they, at that time, instead of building a script to chat with someone like Eliza did, started thinking about how can you leverage this conversational data that is becoming available in large amounts to create a more intelligent chatbot. So all that happened until we see Siri in between, something around the 2010s, and all the way until ChatGPT, which we have today. So just to give an idea of exactly how advanced ChatGPT is compared to these early iterations of chatbots, ChatGPT has extremely advanced functionality. So, for example, if you ask it a question, like assuming it takes an hour to prepare for the drive, how much time should be allotted for the total journey by car from New York City, USA to LA, USA? So the chatbot's brain, if you will, understands that there is a couple of layers to this question. First, that there's a math question, which is that something needs to be calculated. And second, that there's a fact checking question, which is what is exactly the number of hours that it takes to go from New York to LA. And so it does that layering and then consolidates the answer from both those layers and provides the final output. So this is far more advanced and much more intelligent behavior than script-based chatbots or the chatbots that were being developed based on conversation data from the 2000s to the 2010s. So now that we have the technology, why don't we try to use it for healthcare applications? For example,
Kaushik, can you go to slideshow mode?
oh, sorry. Yeah. Okay. So here is an example of a chatbot for uh, helping someone cook that's out there online. So the link you can see in the link at the bottom. So someone says something very vague like, I would like to cook, and the chatbot then just comes back with something generic. And also what do you want to cook, and instructions on how you can use the chatbot, that which is to say you can tell them the chatbot dish names and offer recommendations and so on. And what's unique here is that the person comes back with, I have no idea, right? And the chatbot still knows how to deal with this extremely vague situation. So this at this point is intelligent behavior. So you could, of course, get this behavior through a script, but these chatbots, they're able to get this behavior by crunching a lot of conversational data, where oftentimes the person is not very certain about what they want to cook, right? So and if you have this kind of information from the user where there isn't very specific context, the dishes that the chatbot will provide are the most popular ones in its background knowledge base, right? So, for example, tofu and stir-fried green peppers and spicy crab. It could just as well be mac and cheese, right? But so this kind of output from the chatbot sort of tells you what kind of a database it has been trained on and what people mostly look for. um, so why would we want to use chatbots in healthcare? So I talked a little bit about it when introducing chatbots for healthcare, that where a patient and therapist interaction can be made easier both for the patient and the therapist through the use of a chatbot. But now let's see it in numbers, right? So for mental health care, for example, the numbers are staggeringly high, and it's getting higher every year. The number of people afflicted with mental health disorder in some way, shape, or form. So 1 in 5 Americans experience mental illness in any given year. And in 2023, this number is at 1 in 3. And the increases, lots of articles report it, and it's not showing any signs of slowing down, right? So the AI system is not just something uh, of academic interest here, but it's almost a necessity in these kinds of use cases where the healthcare system is under a lot of stress, and tools that can make life easier for both the patients and clinicians are very welcome. um, so then the question becomes, what kind of characteristics should you expect from these kind of chatbots? Because you certainly don't want them to assume the role of a psychiatrist and start prescribing things to patients, or taking it up to on their own hands to design medication plans and therapeutic routines. So it does need to be defined exactly what is expected of the chatbot in this kind of assistive capacity. So four examples of such characteristics are participatory. So what has been studied in the literature is that when someone is talking to a phone app as a proxy for a therapist, the burden is on the phone app to keep the person's attention. So in a way that keeps them engaged with the app. So that's the first characteristic, participatory. And in being participatory, the app also needs to promote healthy behaviors. Healthy behaviors in what context? Healthy behaviors as outlined by the therapist in the previous interaction with the patient. So that's participatory. And then we have personalized. So it is mental health manifests itself very differently in each individual, and the current context of the conversation and the past history has to be analyzed together to properly engage with the patient. What about prevention? So many times, of course, when dealing with people with mental health, the conversation can go into uncharted territory very quickly. And in those cases, the bot should have the ability to see that coming early enough for directing the conversation to a professional. Uh, the last one is predictive, which is the bot is now equipped with some kind of database in its background, from which it can compute and come up with optimal care plans for this patient. And once it has come up with the optimal care plan, now the question is, because we said that it shouldn't prescribe or in any way act as the doctor, should it relay this information to the patient or not? And for right now, it should not. So you can see that this chatbot, like I said earlier, is meant for both making the life of the patient easier as well as the clinician. So these optimal care plans can later be provided as a summary to the clinician when they become available to take a look more closely again at this patient's case. Okay. So again, virtual health assistants, most people think of them as ELISA type of thing, where you talk with the patient, and that's the whole perspective that they see. But really, again, there are two views. One is the patient view and one is the clinician view. Here is the patient view, where the person can say that I have certain symptoms and I want to know if I can see a doctor in your hospital, and the chatbot can respond appropriately. And then there's the clinician view, which is uh, somebody can tell the clinician that a 67-year-old woman with a history of etc. has just come in, and so then what would be a possible differential diagnosis for this patient, and what could be a workable clinical plan for this patient, right? So this kind of software is coming out almost on the daily. So we'll look at one of them. So here is one, Glass Health here. So let's try the 4 templates that they have here. So if we go with chest pain and go for differential diagnosis, so the description of chest pain here is that a 65-year-old woman with a history of diabetes and um, hyperlipidemia presents with acute onset chest pain and okay, there are a lot of big words there, but there it is. And then once you generate the differential diagnosis, so what's happening while it's processing is it has access to a text database of information that this person may be, the person's text may be suggesting, and it displays that information. So you can see it displaying medical phenomena that the chatbot has observed in this person's text. So here we can see a lot of medical terminology and descriptions for that medical terminology. Now, this is for the clinician to read through and parse any information they can out of it. And the chatbot also provides references. Okay, so now uh, I'm not sure if you type this kind of information directly into Google search, right? Then the clinician has the extra burden of having to sift through all the articles and figure out what is the right article that they can draw from. Or say, for example, an article on Mayo Clinic. Instead, this chatbot can provide them with a starting point for narrowing down their search criteria immediately, right, along with relevant references. So that's incredibly useful to the clinician. So what about clinical plan? So the clinical plan, you can see that it has provided a bunch of tests based on what is written. All these things in the first series of bullets are tests, and the things in the second series of bullets are medications. So for the clinician to look at. So this helps the clinician get started with a plan for this patient. So now these models are um, running their inference on what to do for a particular piece of text background on some large server with a large amount of computing resources. But researchers have now even brought the compute resources down to an extent where it can run on your laptop. These kind of models can run on your laptop. For example, I'll show here uh, a chatbot that Facebook released, which you can chat with. on my MacBook. So if I say hello, so you can see here a problem with these chatbots. So when I said I'm attending a talk on using chatbots for virtual health assistants, the chatbot returns with the speaker discussed a lot of things, right? And the potential benefits include all these things, and I never discussed all these things, right? So um, why am I showing you this? I'm showing you this to show that um, so the kind of output that you saw earlier here um, of generating this piece of text piece by piece, there is really no way for us to tell right now that this output that is generated piece by piece is true or false, because chatbots have the tendency that you just saw here. It will generate something that can be absolutely false but look convincingly true. Although in the first case, in the differential diagnosis case, the chatbot did provide citations. But once again, if you notice carefully, the citations are also generated text. So what can literally happen as a result of a chatbot constructing citations is it can make up citations, right? So now with that background, I'll jump into a chatbot that we have developed here at the AI Institute. It's called Alleviate. Um, so before I get into that, that's not to say that all these chatbots are not making progress towards making this generative process more truthful. But the crux of the problem is that there's no way for us to know because it's a black box system. Okay, so now the huh?
Nothing, go ahead.
Okay, so now yeah, so here for example, this is a system that we have built. There are three templates. So here is a breakup incident text. So what was this system built for? So you can paste here posts from Reddit, for example, subreddits related to mental health, somebody's post. And the idea is that this kind of platform will help the therapist with remote health monitoring, where a patient can just document what they're feeling in a platform like this. And then the therapist can, when they have time, come back and generate an assessment of what they've documented, right? So this will take a while. Okay, there. So what the chatbot comes back with is that the suggested response to this person is, I'm sorry to hear that you're going through a rough time. If you need to talk to someone, I'm here to listen. Uh, so it takes the role of a counselor. It does not provide any new information or, more importantly, false information. It just provides a listening ear. So that's one thing to notice as a suggested response. And then the clinical assessment of this is uh, similar to what you saw earlier with Glass AI, a piece of text that says the text I feel bad about breakup usually means that the person is feeling sad about it. And the recommended action is the recommended course of action for patients exhibiting sadness is therapy. And now the important part is the citation is a link to a database that can be stored in-house that we have built here at the Institute. Uh, Now, I'll show you a little bit of that database and why it is a more verifiable source than just the citation, which can be generated wrongly. So for example, now there's this link. You'll have to find that link in the database. So if we go over to this database, Um, so there's this process knowledge one, and there's the link. That's the link. That's this. This is citing. Now, if you look at this for a while, you see that this is information related to mild depression tendencies, and also that the symptom that characterizes mild depression is over here, which says feelings of sadness, tearfulness, emptiness, or hopelessness. And then the treatment recommendation for mild depression is therapy with a description of therapy, right? So this kind of citation, where you have the link to an actual entry in a knowledge database, is more trustworthy than just generated text, because you can't fake a database, right? So now going back to the I mean, you can fake a database, but these databases are created in consultation with experts. So basically, what I'm saying is the whole database is created by the expert essentially with assistance from administrators that are good at building the database. So there's no false information there. As long as you can find a link to something in that database, the chatbot you can verify that information, assuming it to be true. So you can look at some other ones. Um, okay. Yeah, so again, once again, you see a suggested response, a clinical assessment, a recommended action, and some citations. And you also will see that for here. So here, for example, it's provided 2 citations because it's recommended therapy and medication. So once again, if the doctor wanted to check that this recommendation is indeed correct, they would have to check both these links. And so if we look at, we already looked at this link, the mild depression link, but if we look at this link, it says moderate depression. And there's a couple of treatment recommendations, which is medication and therapy. And the symptoms that would have to be ticked off to satisfy moderate depression is one is sadness, which we already saw. And the other one is angry outbursts or irritability, which you can see in this text, right? I also hate that I can't go out anywhere to cheer myself up. And the chatbot sort of explains that. The phrase "I also hate" indicates anger, irritability. And the citation provides verification to the doctor that the chatbot indeed knows what it is talking about, right? So, um, yeah, so that's the end of my presentation. I'll take any questions.
Any questions, anyone?
Just for my own information, what happened to our ability to show the, patient what we know and the clinician what we know? I saw some of it, but earlier you were showing the tree and all that stuff, right? So just didn't want to show the details of that kind, yeah?
Yeah, because I had to render the HTML page and I did not want to show it on the terminal. So, yeah.
Yeah, go ahead.
How accurate is it? Because sometimes you can have the same diagnosis, like the medical there's certain levels don't get the degree, is it just the best and give that same?
So I just want to give you, so we step back and kind of address this question broadly, and then maybe they want to add something. What is happening is that the systems that are being built, this chatbot, many of them are built by using very large amount of data. But there is much less control. So these AI techniques that try to process large amount of data and understand something from it, and then when you ask something, give response, they have high chance of sounding confident, as you are showing, but be very wrong. So this technique, by the way, in the AI is called generative AI. And these are, the ChatGPT is indeed the good example, generative AI. Tomorrow we'll show you how do you make up fake images, and those, or even, do a lot of things with images, and you will see that there are a lot of things that these systems do, but then they don't understand what they are talking about, but they kind of synthesize the words in such a way that it sounds very legitimate. What Kaushik tried to show you, and what was very important here, is that this interaction or any activity of AI algorithm needs to be constrained with real knowledge. So think about why do we expect doctor to do better? We expect doctors to do better because, first of all, they go through rigorous training. So for the mental health, there is a learning, there is a big kind of medical text called DSM-5. And anybody who gets clinical education in mental health, depression, anxiety, all kinds of things, they go through those texts in a classroom like this, and they then go to the real world in practice, and they have the residency and rotation residency and all that, and they see real patient, and they discuss the cases with attending doctors, the ones that are already doctors, and they learn from that, right? So because of that, what my group here does, what we do here, that is different, and that's why Kaushik first showed you the chatbot that was generative AI, and then he showed you ALLEVIATE, which is our system. The difference is that other chatbot, which created that all this long text, was all trained from, for using text, and it did not really understand what it is talking about. The ALLEVIATE that Kaushik showed about, that on the other hand actually uses medical knowledge. So this knowledge is created from DSM-5 or the particular mental health related resource. It does not promise to do everything. It promises to do just mental health. And that also subset of mental health. It does not deal with suicidality. It does not deal with schizophrenia, which are very heavy, very complex and difficult mental health problem. It deals with little less complex mental health problem or less severe mental health problem like depression and anxiety. And in there, even when we develop that, it's very much driven by the knowledge first and foremost, while using the generative AI techniques to make the text sound human-like, or make it a human text, understand the human text and respond in human text. So there's a knowledge, there's reasoning that you can do from knowledge, and then there is this generative AI that makes the communication human-like. In this context, for this, we are making very concrete effort in ensuring that we don't fall into the trap where it looks confident, but it's actually very wrong. Even after this, our chatbot has to go through evaluation by actual medical doctors, clinicians. So we would go through a bunch of interaction with the patients, and this will make the response like as you saw, and the doctors would check and evaluate and go through a process of validating that it does very well. Now, we are at a stage where there's going to be some problem in that we can do very well, but we may make a mistake 5% of the time. What do we do? And we have a very strange dilemma. Doctors are wrong very often, but we accept that. So there have been evaluations where, particularly in radiology, for tumor detection, part of the software, AI has been, proven to be, computer vision, algorithms have been proven to be more accurate than the doctor. But but I think the humans would have problem taking an algorithm that is less accurate than the doctor, but is not a human expert. for that, we are pursuing an additional strategy, and that is called explanation. So suppose my software is, so what happens is that when doctor if he works with the patient, he or she needs to write down medical record and explain why, what are all the labs, what are all the symptoms and other questions he asks and answers, and what is his interpretation, and what, and he follows medical guideline. So every discipline like cardiovascular doctor or asthma specialist, they all follow clinical practice guideline, which essentially is a bunch of if and then or processes saying, make sure you do this, make sure you do this, you rule this out, and then you get, to the solution. So what we are doing is that when we use knowledge, we are also incorporating medical guidelines. And then when we give you the answer, we give you explanation as to why and how we came to that result. Thus, there is a much better chance that if there are errors, those are captured, and that any output is rooted in that knowledge and that process understanding. And that is what, that's how we are trying to make a difference here. But I think in the process, though, what I try to describe you here is that is one thing to kind of talk intelligently, another thing to understand. And they are very different thing. And you need to, you have different branches of AI, they deal with that. So a class of system that we work in this place is called neurosymbolic AI. Neuro means neural network base, which is this generative AI working or using deep learning algorithm and such. And symbolic means use of this knowledge, variety of knowledge, and combining the two. Yesterday also I had made remark that we humans, a system 1 and system 2 remark, I think you may remember. So system 1 is fast processing, system 2 is deliberative processing, slow processing, and that humans can do both of them and combine them. So after a lot of first, there was a system like ELISA, and they were not very successful in the real world. But they're very interesting in those days. If you're talking about last century, and what they're doing very interesting, but they never reached, any real world use. Those are symbolic AI system. Then came the statistical AI system in this century. Especially, first came machine learning, starting around the start of the century. And in 2012, the most important paper, for the recent thing on deep learning came out. And then again, big inflection happened when in 2017, paper on transformer technology came about. And that, is the one that is right now behind ChatGPT. So the deep learning made a lot of progress with text understanding and, and natural language processing and language translation. Now this transform model has made amazing progress with interaction and conversation and chatbots, and even, other things of generating pictures and everything. And now we are trying to take this to the next level where, while generative AI is doing fantastic job in some things, as I said, for many things still, because of the accuracy and reliability and explainability, we are working on this next generation of neurosymbolic AI systems. Your question?
So since AR are becoming more like intelligent,
Yeah.
Like what barrier is set between the AI and the human as far as like emotion goes? Like if a person has mental, like let's say anxiety, or they feel comfortable enough to talk to the AI necessarily, and they want to kind of like know the problems, information, meaning that the AI is a computer, of course, they have no emotion. It's like, is there information?
Cognitivelabs.com.
Is there information that is in the database, you know, that, you know, I just kind of want to questions, like, what's the barrier as far as emotion goes, and like to let the person know it's interacting with the AI. Like, I'm still a computer, and then my second question is there, if the person is in communication with the AI, like, this needs, so like, the person with the AI. Technically, the second question is like, is the person's interaction with the AI?
Wonderful question. Let me take you, you ask about emotion. You see there's a company called Cognovi Labs. I founded that company. This company is emotion AI company. So this company, understands emotion towards coronavirus in general, emotion also. So you see there are a bunch of emotions, and fear, disgust, sadness. So I was at the previous university, I said university, where students like Vedant and Kaushik worked on with me on software, which then I licensed to found this company. I am not running the company. There was a company before that I ran earlier myself as CEO, but this company, I founded it, and then few of my students are the guys who are actually running, doing all the technical work that you see here. So there are two-part answer to your question. Your question is emotion and AI, it's a complex question, but very important question. Particularly, your question also goes towards human-like. How much is AI human-like? Can it be ever human-like? So there is a lot of things to discuss about it. It's a very good question, and I'm happy to discuss that with you right now. Yeah, can you put it? Oops, is it gone? Can you turn on the light also? So understanding some human emotions in text is quite possible, and that's what this thing shows you. But there is also a word called situated intelligence or grounded intelligence, in the sense that it's one thing to have understanding of text, emotion in your speech, in what you write. This is emotion from what you write on social media. And actually, this guy Vedant works on a project where he took 8 billion tweets, and then he tried to understand how the government policy of school closure versus wearing mask versus closing the schools and businesses affected people at different age and all that. That is easier, but situated intelligence or grounded intelligence says that we humans, the doctor is observing the patient, and doctor may ask you how severe is the pain on 1 to 10, and you may be very tough guy and say I am 5, and the other person may say 7, but your pain may be higher than somebody saying 7, right? So there are a lot of aspects that humans have and understand about emotions and other feelings that current AI systems broadly don't have. But it is, while most of the AI that you have heard and seen is about text that you have seen, and you'll see tomorrow a little bit more about the images, but the same AI is applicable on sensors, sensor data. So there are a lot of sensors. There is a sensors with the watches that are available, and Fitbit that will tell you your oxygen level. They will tell you your perspiration and physiological thing that happened because of, let's say, fear or stress. So there are sensors available that measure stress, as an example, and that can be immediately brought into the AI system. So the AI systems are going towards situated and grounded intelligence, where the emotions and feelings will become part of what they understand. Okay. At the same time, there is still some time to go. So that is an area of very strong research that I think we'll start seeing products in 5 years or so. What was your second question? Oh, yeah. If the AI systems are recording what you're saying. Yes, yeah. So what could happen is that when you're interacting, first of all, when you're talking to ChatGPT, every question you ask and every interaction you have, it is logging. And it is improving by itself. There are humans who also look at the answers and they are using it to improve themselves. So all those terms and conditions you agree actually allows them to record. The second thing is that there have been cases where you give your personal data and it has actually showed up and gotten used by the system for some other purpose. And if you're not careful, somebody can maliciously use the data to harm you also, harm you not necessarily physically, but your interest. Like they can fleece you, they can, scam you, as an example. So you really have to be very careful. Again, on the 4th day in the fake news, or tomorrow, one of these days, tomorrow or day after, we are going to go through that. Both the trust is actually tomorrow. Thursday morning is trust. And we are going to talk about some of these issues. And also we're going to talk about fake news and others, where we'll discuss the issues of this kind. But yeah, so what is happening with AI is that some of us, and there is a kind of a divide. Some people are extremely, can you bring up the cartoon I shared today? LinkedIn, go to LinkedIn, go to my thing. So I'll show you some very interesting cartoon that I just shared today. Just get my name here and go down to the post. Yeah, this one. Yeah, this one.
This one?
Yeah. Make it larger. So let's look at this. We guys, you guys need ChatGPT, right? Look at this. Wait for a second. It's funny. So it makes up things. Kaushik showed you that. It makes up things. Will it take jobs? Indeed, it will take jobs. It is taking jobs. Well, part of the reason it is taking jobs is that right now these companies using AI making massive amount of money. Especially they made a huge amount of money when people were all online, not going out because of COVID. And yet, Facebook, let go 22,000 people. Microsoft let go 12,000 or such number of people, and so on and so forth. Google also. What is happening because of the AI? Productivity is going up. So programmers, especially on the lower end, are becoming dispensable. We showed you a little bit about writing programs using ChatGPT. We showed you just the less than 1 of 100 on the scale of 1 to 100. We just got you started at 1. There is a lot more you can do in terms of programming with the these systems. And I'm constantly having debate. Jinendra, who sits in the back, tells me no, it's no good. And I keep on challenging him, says better than you think it is. And then we keep on saying more evidence every day that it is better and better. And yet it is not ready to replace all the programmers, but it is ready to replace 50% of the things simple, very low-end programmers do. But it's always like a pyramid. A lot of people do a lot of basic things, and very few people do very sophisticated things. There's nobody there to replace the people at the top. But the people at the bottom, this technology is going to replace more and more. So you have to be very agile. That's why I also made a very in a comment that is important for you guys as you think for your career. That we should not think about AI just as for programming or as computer science. We should think of AI more from what it does for mechanical engineering, what it does for manufacturing, what it does for materials, what it does for health. So in that context,
Just just to the point that you mentioned, it's only taking the lower level jobs. This is an example of taking away the higher level job. So this company made an AI CEO about a year back, and they saw share surge and profit like they haven't seen before after they was appointed as CEO. Yeah, means of course the decisions are made.
yeah, so to the extent that you're collecting the data well, it is possible that machine is faster and better than the human is, because it can decide without emotion, because it does not care about how many job is lost. He's only looking at how much money you're making, things of that nature, many of those things. Yeah, go ahead.
I just want to ask though, like, how can you trust that the people that program the AI part of like,
Okay, so as we showed, you should not always trust it completely, and there is a lot of challenges in terms of trusting or not trusting it. You have to become discerning. You need to really pay attention to when I can trust or not. That's why I make a big deal about explanation, that you don't want to trust. You remember, there's we had a president earlier who coined this: trust but verify. Right? Ronald Reagan said that. Before, you really need to figure out a way to verify. And so that's why the explainability is very good. So IBM did a survey asking companies about AI, and 91% of the companies said they want explainable AI where I can explain it. But most of the technology that we have today in AI is black box AI. They cannot explain themselves why it is. And you did, Kaushik did show you, for example, reference and all that. There's a lot of mistakes going on there. So, it's there, may look correct, but doesn't mean that it's correct for sure. So no, you should not trust AI. We're going to talk about that. Whole session will be on trust on Thursday. Yes.
So back to the ALLEVIATE AI, one of the things you said is that it's less likely to not likely at all to make mistakes with its diagnosis because the data that it's taken from a more trustworthy source. So is that due to the fact that it's available data, it's smaller in scope, or is it just because of the way that you're accessing it?
Kaushik, the question is, why did you say AI, ALLEVIATE is more trustworthy?
Oh, okay, sure. So in the Glass AI demo that I showed, first I showed the fact that Glass AI can generate citations for what it's saying. And then I sidetracked to a different generation context where I showed how generative AI can make up things. So here's the conclusion, that the citations that Glass AI generated, it can be completely made up. On the other hand, the link that ALLEVIATE provided as citation is an actual link that exists in a database, right? So you go there and you verify with the information present at that link and its association to other links that the explanation that ALLEVIATE provided is indeed true or not. If hopefully that answers the question. So
We are accessing it.
Yeah, so what's the difference?
The difference between Class A and ALLEVIATE?
Yeah.
Kaushik, you want to answer that question? What's the difference between the way we are accessing the correct data in Glass AI versus the way we are accessing it in ALLEVIATE?
The difference between the way we are accessing the data in Glass AI versus Alleviate.
Yes.
Okay, so the simplest example will be making an analogy with Google search. So imagine now, instead of Google search providing you links for your query, if it just provided that as plain text, right? So you could not click on anything, but it was all plain text. And now imagine someone showed you that plain text that the AI behind Google search generates can make things up. So now you can't trust that text anymore, even though it looks like a perfectly valid citation. On the other hand, the link that Alleviate put out, it's not generated link. It's a link that exists on a database, just like Google's database. And you can click on that link and you can verify the information. So that's the difference in the access to the knowledge. It's text-based knowledge versus a database of links as
So
knowledge.
think of it as the knowledge that we are using is providing guardrails, and that you are able to connect what you are saying in terms of your response to the specific things. So you know where you need to latch on, what supports what your answer has statements, and we know what is a supporting statement, what is based on what that we are generating, as opposed to generating those statements through a very large a matrix of a vector of what happens is that these deep neural networks essentially generate vectors, and this vector are showing the probability that this word is connected to this word. And particularly these things do well when there's a lot of supporting data, but many of the cases probability is very low, and then it kind of makes the call, and it has more chance to be wrong when it is working with cases where there's very low probability connections between the words and facts. Yeah.
So Alleviate is finding those things without applying a stochastical process to it.
No, it does.
So it still does.
But the point is, so in simple terms, if I want to explain this to you, in case of Glass AI, a system already has all this data. So it's like, think of it as a person.
So it's internal.
Yeah, means
It has
both the
computed
case-
all the probabilities. It has all the vectors done from the data it has processed.
Yes.
Like that, like some doctors and some those courses thing, right? That they can creative system. Is there then, so I can see where AI, is that first step to kind of eliminate those impromptu,
Yeah.
But then I'm wondering if it's that with the like really rare diseases, particularly in subsets, that are, how does it, I know all of that's in those medical manuals, but like the really extreme, like, and I mean, this alleviates for the mental health, right? But it wasn't really schizophrenia. But I mean, how do you, I guess, ensure if there are, if I'm not, a clinician, but if things present differently in different subsets, like disease versus adults, how does the computer?
I think you made several points essentially, or the what you said actually can be dissected in multiple ways. One thing you said was that you can use, I think there is a value of these systems for training. I think that is, more than making these available for direct use by patients. I would consider the use of this technology first for training after testing. Now, one important statement I made is that we don't plan to make Alleviate out there on the web and say, make your thing. We plan to work with actual doctors. So Dr. Meera Narasimhan she runs a clinic in here at the Prisma and AUSC on this topic. On Monday, we have, actually at 3 o'clock coming Monday, we have visitors coming who are doctors, mental health, who are developing mental health program for the rural South Kenya. So we are working on, we would be evaluating it, and we will be making the, first we are evaluating it. Secondly, in our work, we are doing explanations. So we are showing what we are saying by linking it to the knowledge that we have used in saying what we have said. And we refer to, for example, the medical, suppose we say this is OCD, then we'll refer to the medical definition of OCD and show you why we think it is OCD and why it satisfies the definition of OCD, and not just say it is OCD that we create. So it's one thing to what you call as a classify, a text into an OCD where you don't have to understand anything. You just have to have most probability that this text best fits this node and not that node in your taxonomy, but not understand anything. Other thing to actually map the components of the text, the phrases, the entities into the concepts that are used to define, make a definition of OCD or whatever medical concept is, and then say this is why we are doing it. So these are the two of the very important reasons why I think what we are doing would have more likely better accuracy. But again, I can only say more likely because we have not yet completed all the evaluations right now. We are just getting set up with that. What we can do say that is, yes, we are able to use the knowledge. We are able to show a better performance compared to the state-of-the-art generative AI techniques. We are not making the kind of mistakes that they are making because we can show them. You don't need medical doctor to show that kind of thing, and that we are able to generate pretty reasonable explanation. These are the things we can show right now.
Any more questions? Anyone? I think we are just 3 minutes over the time.
All right. Thanks, Kaushik. It was a good one. Shall I stop?
Yeah.
Thanks.